This is my job today.
All
right.
On late starts, you're not available in the morning? You're not available in the morning for late starts?
Yeah, meeting. All right, everybody, have a seat, please. We're going to get started. Right. So, basically, real quick, I'm going to pass back papers, and we're going to go, I'm going to give back your lab. If you have a question about the test, we've got about 10 minutes slotted in, and we can actually work on the test. All right, we can answer a question about that. Then we're going to, moving on to our next presentation, which will be our next topic, which will be about chemical equilibrium. The test tomorrow, or no, your test is on Thursday. You'll have 15 minutes to take the test, so if you need extra time, if you want people to have extra time, you need to make arrangements to do that outside of class before the end of that day, all right, or at the end of that day, one of the two, all right? So you need to make sure you talk to me today and make sure you figure that out, all right? All right, cool. I'm just passing these back. These are your quizzes that I think we went over before, but apparently. All right, I'll be passing that back later. All right. Are there questions about the test? The review, just so you know, is on your OneNote page with the answers are there. We've gone over the other problems before that, so if you have questions about any of that, you can ask now. You can take a look at your review problems from the other day. Make sure you know that. Okay, I'll take that further. All right, so today we're going to be talking about chemical equilibrium. So in our last unit, which we're having a quiz on Thursday, we basically had this kind of reaction, right? So if we read that question, all right, we've got, that balanced equation. Is it balanced? Yeah, all right. So how many moles of hydrogen gas will be produced? We have 2.5 moles of zinc. 2.5 moles. And why? It's a 1-to-1 ratio. Very good. Okay, so basically, in that kind of reaction, where we're actually taking acid and we're adding to the zinc, did we do something like this in class? Yeah, we added acid to zinc before, right? It had all the things, right? So we get on to conclusions, right? So that may not always be the case. I've got something to show you back here. All right, so take a look here. I have my three solution. All right. So if we're going to describe it, what would you say, Nick? Peachy color. All right. I don't know, 3/4 the way full, right? So if I do something to it. Something happened? There's a slight color change, all right? Well, now, is that reaction like the one we saw up there? Maybe. Well, what do you mean by maybe?
I don't know.
Well, did it go to completion?
It's back.
What's back?
Color.
The color.
Oh, it's white. Clear.
Right, so so we can do it again, right? Here, can you put your finger on top of this, Nick? Okay. Can you shake it? All right. All right, well, you got that technique down. All right, so what are we going to call the reactants in this? We want to call the things we start with. What do we start with? Come on, Nick, you described it.
What's the question?
What do we start with in this reaction?
Clear.
Okay, so I thought you said peachy, all right? I just want to make sure I'm true to what you said. You said it was kind of a peachy color. So then our product was a purple color, all right? But is this staying its product? No. So is this the same kind of reaction that we've been looking at before? No, this is a reaction that's kind of reversible, right? Because we can make our reactants come back, all right? Any ideas of what making that reaction go on? We're going to come back to this. Any ideas about this? What do we know is what's going on? What can we say is in this as far as reactants? Give me one thing that's a reactant.
Probably water.
Okay, you think it's water? Okay. Anything else? What do you think we're starting with? Is there something in the water? Okay, there's something in the water, okay. So we got something dissolved in the water, right? Is there anything else in here that's a reactant?
Aqueous solution.
Okay, so it's an aqueous solution, so there's something dissolved in the water. Is there anything else in here? Is there anything else in there? Air, all right? So basically we got three things that we can say. We got kind of a liquidy thing, we got something dissolved in it, we got air, all right? So when I shake it up, what might be happening?
The air.
So the air might be actually interacting with that, all right? Where you can actually have the air has some kind of way of interacting with the liquid that causes that reaction or that chemical in there to change color. What's in the air? There's two big things that are in the air.
Oxygen.
Okay, that's one, and the other one would be nitrogen, all right? So, we'll go with oxygen. I like that. All right, so we'll go with oxygen. So, what does oxygen do to things? Oxidizes things. So basically when I shake this thing up, all right, what am I doing to the solution?
You are
I'm oxidizing it, but then over time, it must do what? Well, if you unoxidize, you, so it's got something in there that we've got some cycle of this indicator. There's an indicator here called methylene blue that's going back between its oxidized form and its reduced form in the presence of that material that's in it. All that? Now we're going to look at a couple other things here real quick. So what we've got is, we've got a reaction here between nitrogen dioxide, all right, and dinitrogen tetraoxide, all right, and it has a reaction that it goes from this to this, and we're actually going to take a look at what it looks like, all right, and I got it already up here. Okay, try again. All right. Are we not working? Awesome. Okay, I have my order. All right. Okay, so basically, we'll get out of that because it doesn't want to work anyway. Sorry. My backhand here. That's what my PowerPoint died. All right. So basically, what we have is we have a reaction. All right, and that reaction is between those two different materials. All right, and my nitrogen dioxide, and it converts into dinitrogen tetraoxide. All right. right? And it also gives off heat. Well, sadly, the video died, I don't know why, but basically what goes on is we can actually put this in in tubes, and we can expose them to different temperatures, all right? So we can put it in hot, we can put it in room temperature, and we can put it in cold, all right? Now, what happens is when I put it into hot temperature, the solution is dark brown. And that dark brown color is associated with this. Put it in room color temperature, it's a light brown. Right? And when I put it in cold, it actually gets into almost a tan, like a super light brown. Now this is actually colorless. Colorless, right? So, basically what's going on in each of the different temperatures then? Which thing is dominating based on the temperatures?
What do you mean by dominating?
Well, okay, so, in other words, in the different temperatures I got it at, hot, room, and cold, and it kind of being kind of vague there, which one of the products, or which one of the substances is there more of? Is there more nitrogen dioxide, or is there more dinitrogen tetroxide?
Dinitrogen tetroxide.
In what color? In what temperature? Okay. So if it was all dinitrogen tetroxide, what would it be? What color?
Cold, it would be colorless.
It would be colorless, all right? Call that. And if it was all nitrogen dioxide, what would it be? Dark brown, all right? So, in room temperature, what can you say it is? A mixture, right? Okay? In fact, you can really argue it's a mixture on all of them, right? But in the cold, which one do you think there's more of, this or this? Okay? In this one, there's more of that, all right? In the hot, or when it's hotter, then there's more of this, all right? So what we're actually doing is we have a reaction that can go either way, all right? So when we start talking about these reversible reactions, we're actually going to use, instead of one arrow, you basically use two arrows in the fact that it can go from your reactants to your products, or your products to your reactants, but in reality, it can either go forward or backwards, or forward or reverse. Does that make sense? Okay? So that's where we're going to leave it at that point. What we're going to do now is, I've got a POGIL that I want you to do, and what I've got is, I've got job assignments on each table. So you need to decide which job you want to do, and you have 8 minutes to actually work on the first 6 questions on this POGIL, all right? And be prepared to... that to tie into this idea that we have react.
I just trust you to manage.
I'll present.
You can report it.
Here.
it goes like